Okay, so homework for today was to add some color commentary to our death match. Maybe add some randomness to how hard somebody hits, that kind of stuff. Okay, so right now we already have some functions. We have this fight to the death. We have another function called display fighters. It just kind of shows us the current status of the fighters. I'm going to go ahead and create, just to compartmentalize this a little bit, I'm going to create a function for the homework assignment. I'm going to call this guy def. Let's call it, how about just attack? So let's call this source destination. I don't know. So the source is who's attacking, the destination is who's being attacked. Something along those lines. All right, so we'll just go ahead and bring it up to date with what we have right now. So when source hits destination, right now we are grabbing the attack power. So I'm just going to go ahead and grab this line right here, and we'll update it. So we are updating destination's hit points to be whatever his current hit points is minus source's hit points. That makes sense? So now I've written a generic function for this. So now down here, I can say attack, passing it in, source is, and this one is what, P1? Destination is P2. And then for this one down here, attack source is P2, destination is P1. That makes sense? Okay, so I'll go ahead and run this just so we see that it does the same thing as it did before. I haven't actually added any additional logic. I've just generalized one of my lines of code so I can call it more conveniently. All right, so there's my fight to the death that still does the same thing. So this is player one. Looks like they won that one. Okay. So now we want to add some, maybe some randomness. Let's start off with that. Then we'll add in some color commentary. All right. So what I'm going to do is I'm going to have a function here called get attack damage. Okay, and this guy will take in a player as a parameter. And what this will do is I'm thinking maybe attack damage will be some amount of damage between 1 and that player's attack power. Something like that. Okay, and remember we have this rand_int function that allows us to give it a starting point and an ending point. And is this inclusive or not inclusive? I think it was inclusive. Yeah, so we originally did like a rand_int 1 to 10, and it gives you 10s, right? Okay, so for our get attack damage, we're going to go ahead and return rand_int between 1 and player at bucket attack power. So that'll give us an amount of damage between 1 and attack power. Does that make sense? All right, so then down here, inside of attack, rather than subtracting source attack power, what we'll do is we'll say get attack damage from source. That'll add some randomness to it. Okay, because I built my randomness into get attack damage where I pass it some player and it randomly generates an amount of damage between 1 and that player's attack power. You kind of see the benefit of putting these things into little modules like this. And we've really changed very little of our overall logic, but we've really kind of generalized stuff where now we see with, oh, I can use this for all sorts of players, and I can use this whenever I need somebody to generate some attack power. I don't need to worry about what his current attack power is. I just pass him to this function. It gives me a number back. And that's how hard he hits. Okay? So we'll go ahead and run this, and we probably won't notice a substantial difference because the randomness is kind of built into it, but he won't always hit for the same amount. Now it'll hit for a different amount. We can even do something like here if we want to see the different amount. We can say damage is equal to this. We'll subtract damage from this guy. And then we can say something like hits for string version of damage. Just so we'll see randomness in there, proving to us that the random stuff is working. So every time we attack, we'll just print out how much damage we attacked for. Oh, I used the capital I somewhere. All right, so we hit for 3, we hit for 1, we hit for 3, hit for 2, 1, 1, 1, 3, 1, 2. So some randomness in there. Okay. So now, if we're going to add some color commentary to this, so that was all we needed to do for attack, right? We didn't have to incorporate it in defense or anything. I suggested you could if you wanted to, but that wasn't part of the assignment necessarily. All right, so now we have to add some color commentary to this guy, where we want to give some indication of how hard somebody hits. So what we can do is maybe we decide the damage that the source has. If it is their maximum damage that was generated, we can say something like he hits really, really hard. If it was the minimum damage, it's a 1. He barely grazes them. And then something in the middle is, bludgeons him or something like that. So maybe we kind of have three different levels. So we can say something like damage string. We'll just say an attack. Something like that for starting point. And then we'll add in our adjective. How bad was it? Okay, so we'll say if damage is equal to 1, we'll say damage string is equal to damage string concatenated with grazes the opponent, something like that. Elif damage is equal to source at attack power. That means source hit for as hard as source is capable of hitting. We'll say damage string, let's just do liquefies the opponent. I always like that one. Else, we'll just say damages the opponent. And then we'll just print out our damage string. That makes some sense? So kind of three different layers of or levels of damage. barely hits, really hits hard, somewhere in the middle. So out in here, so we have damages the opponent, grazes, damages, grazes, oh, liquefies. Man, if only we could have graphics. Damages, grazes, damages, damages. And in the end, player 1 won that fight. Player 2 should be able to win sometimes. Yeah, there we go. Well, no, player 1 won again, but it was close. Player 1 won again. There we go. Player 2 won. All right. So, questions on that? And so we pretty much took the logic we already had there. Now, we didn't have to suck some of these things into other functions, but it certainly makes life easier, right? As we're going through and we're fighting to the death, each time through we're displaying our fighters. Then what are we doing? You know, depending on whose turn it is, either player 1 attacks player 2 or player 2 attacks player 1. So we built an attack function rather than just having a line that looks like that in there. Okay, so now, would we say that this is starting to get a little bit messy? You know, we're using dictionaries. We're kind of storing different pieces of information about our objects. But things are, you know, if we go back to when we talked about the difference between procedural languages and object-oriented languages, we kind of mentioned that we used the example of the procedural version of a telephone versus the object-oriented version of a telephone. The object-oriented version of a telephone looks like a telephone, so all the wires and stuff are hidden inside the little container, and it looks like a phone, but you know, we know all those wires are still in there. All right, so we're going to introduce objects, and we're going to convert our players into objects. All right, so we're going to say objects. We're going to start off by saying, like a dictionary, except it can also contain functions. Okay, like a dictionary, except it can also contain functions. Technically, dictionaries can contain functions because you can associate a function in Python is a value. So you can associate a function with a variable name and then call that multiple times. But don't worry about that for right now. That's not something you would ever consider doing for a while. All right, so objects are like dictionaries, except they can contain a bunch of functions. Objects have 3 members. We have fields. So these are name value pairs associated with the object. So that sounds a lot like what dictionaries were bringing to the table. All right. Then we have constructors. So these are the initializer functions that give the initial state to an object when it is first created. And then we have functions. And a lot of times in object-oriented languages, they start calling functions methods. But these are just synonyms for each other. A long time ago, I'll just give you a little history thing here. This isn't something I'll necessarily test you on, so we'll say history of function-like things. So a long time ago, we had subroutines. That's what they were. Called. You've maybe heard that word in a movie at some point or something like that. But it's a very old term back from the basic programming days. The language called BASIC, not Visual Basic, but BASIC. All right. So we had these things called subroutines. So here I'll connect this to BASIC. So that's basic programming language. So then in a language like Pascal, we had procedures and we had functions. Procedures did not return a value. Functions did return a value. So we've talked in here about functions that either return a value or don't return a value. Sometimes we print something out or do something just inside the function. So even if we go back out to our code here, get attack damage, this is something that returns something, right? We've asked it to give us a value back. Whereas display fighters doesn't actually return a value. In this, it could just do math and not even display anything, but in this case, it just displays some information for us. It does not return it for us to use someplace else. Get attack damage allowed us to say, I want to get attack damage from source, and whatever he gives me back, I'm going to store in this variable called DMG. That make sense? So we commonly write functions that sometimes return something, sometimes don't. That's a common thing for us. In some older languages, they used to have two separate entities for describing that kind of thing. If you were going to write some logic, a reusable chunk of code that did not return something, you would create a procedure. If you were writing a reusable chunk of code that did return something, you would write a function. All right. Now, more modernly, go ahead. Do you have a question? So more modernly, like in, let's just say, C and onward. Actually, why don't I say C for right now? We have functions which can or which may return a value, but do not have to. C++, we can say renamed functions, methods. More of a naming convention for object-oriented languages. Naming convention for object-oriented languages. And maybe you've heard me use those terms synonymously. You've maybe heard me say methods before, just because I'm teaching so many different languages at different times. I just will throw it out there. Methods, functions, same thing in terms of what they actually do. Currently, I'm sure there does exist a language right now where there's still a distinguishing difference in syntax between a procedure and a function. What we'll see in Java next semester. See, right now we're working with a loosely typed language, so we don't have to define the type that a function returns. So there is no distinguishing syntax between a function that returns something and a function that does not return something. In Java, though, we have a return type. We have to specify what kind of value a variable is built to hold. We also have to specify what kind of value a method would return. And if a method returns nothing, its return type is called void. If it returns something like an integer, its return type would be int. If it returns a string, its return type would be string, so on and so forth. All right? But from our perspective, functions, methods, procedures, subroutines, these are all synonymous terms. All right? They all mean a reusable chunk of code that we write once and can call multiple times. As programmers, we need to be aware of whether something returns a value or not, and then we have to decide, do we want to do something with that value that it returns? Make sense? Because it's perfectly legal for me to just say this. I'm going to call get attack damage, pass it my source. Get attack damage is going to give me a random number, and it'll spit out that number. So what I have highlighted there will boil down to some random number between 1 and source's attack power. And what am I doing with that value? Right now, the line I have highlighted. Am I doing anything with it? I'm not storing. I used to say this. I used to say damage is equal to that. Not right now. I'm choosing to just ignore the value. This was a complete waste of time in this particular case. Make sense? Now, if this function also did some other mathy stuff and updated some variables and maybe printed something, if it did some other stuff, I could say, well, this might make sense. You know, I didn't actually waste my time. I just chose not to use the value it was sending back. Nobody makes us use the returned value from a function. But the idea is you probably called that function because you were interested in that value and you were going to use it for something else. In our case here, we are interested in that value because we intend to use that value to reduce the person's hit points. Make sense? All right, so these guys are all synonyms with each other. Where if we were having a class 15 or 20 years ago, that lesson might be a little bit different. And technically, we would have to throw some context in here. If we were learning Pascal right now, calling a procedure a function isn't necessarily accurate. But it's accidentally mostly accurate to begin with. There's just a distinguishing factor between whether it returns a value or not. We don't need that anymore. What's actually interesting is we didn't actually need this back then because Pascal was a strongly typed language, just like C. So they could have had a single syntax that allowed us to say what kind of value this function is going to return. So really what was missing in the Pascal days was the invention of the word void for most of our modern languages. We had no way of saying this function returns nothing. We didn't have that, a keyword that indicates nothing, nothingness. All right, like in Python, we have the keyword none that represents nothingness. We didn't have that in the Pascal days. So instead of inventing one, they just decided we'll have two separate syntaxes. One that is a function that can return anything that we do have keywords for, and the other one that won't try to return anything because we don't have a keyword to say nothingness. Make sense? And what makes it even worse is Python actually did have a keyword for nothingness called null, which you just chose not to use as a return type for functions. What are you going to do? It was created as a language for teaching, so they only put in 80% effort. All right, and I won't test you over this. This is just really giving you a context of, you'll hear me say functions and methods kind of interchangeably and just kind of roll with that. It's the punchline. Probably the most correct thing to say is object-oriented languages have methods. That's probably the correct way of thinking about it, whereas procedural languages have functions and possibly procedures depending on its vintage. And I guess possibly subroutines if we have a finely aged wine, from a long time ago. But pretty much all our languages today are object-oriented languages. And for our first time today, we're going to use Python as an object-oriented language. Okay? So what I'm going to start off by doing is we're not actually going to update our player yet. So I want to still keep some of the dictionary junk in here just so we can kind of see the advantages of the objects. So what we're actually going to do is we're going to write our own class for a dice roller. Okay? So if you're one of these folks that play Dungeons and Dragons, or anybody in here ever played tabletop Dungeons and Dragons? You bring your little bag of dice. I used to have dice made of asteroid. Way back in the day, I was a professional dungeon master. Would go around the country. It was way back when I was like your age or younger. I would travel around the country to conferences and run the Dungeons and Dragons campaigns like for 24 straight hours. And so, Dungeon Master has to have the cool dice, right? So I had this like thing went around my neck, like it was like my source of power. Oh man, people were jealous. Yeah, you take it out and they were like these little dice, but they weighed like tons because they were actually made out of asteroid rock. Like a D20 was like $400. Yeah, people were so impressed. I don't know where they are today. I almost guarantee they are in my house somewhere. They made the move. At some point, we'll have to have like a pizza party / scavenger hunt at my house. we'll go downstairs and like keep all my Magic Gathering and all my cards and stuff for those things. We'll see if we can find the dice. But then if you're a tabletop player, you also probably have like the box or the bag of just zillions of dice, right? That you've collected over the years. So, a D20 is a 20-sided die. And if you're a Magic the Gathering or one of these card game players, you probably just have one of those because it's amateur hour. All right. So in any case, we're going to create objects for representing a dice that has some number of sides. Okay. So I'm going to come up here and, well, let's just start in Keynote. Our keyword for objects is we have a class. Okay, so classes have, I'm going to kind of introduce a couple of things here. We have this thing called underscore init underscore. It's kind of a funky syntax for Python because object orientedness was kind of bolted on to Python after the fact. It's also a little bit weird to implement object orientedness in loosely typed languages. Obviously, it can be done because Python's done it. It's just a little bit weird. I think you'll probably find the object model in Java and C# to be a little bit cleaner. But this isn't that. It's just you have a couple of little weird things like why did they throw underscores there? Well, just because. They just did. So this is our constructor that I talked about on this previous page. And we'll see one as an example here in a second. We also have this keyword, and this keyword is super, super, super important. I can't emphasize it enough. It's a keyword called self. Self is how an object refers to itself from within itself. This will be a little bit difficult for you to wrap your mind around at first. I'm going to try to give you several examples so you can see how this works. But super important word. If you've worked in other languages before, the this keyword is equivalent to self. If you've worked in Visual Basic, the me keyword is equivalent to self. So we're kind of seeing those similarities between languages. Next semester when you're doing Java, we're going to be, instead of saying self, we'll be saying this. This is how an object refers to itself from within itself. Means the identical thing, just a little bit different keyword. All right. I'm going to stop with this for right now, and we're going to write a simple object. So I'm going to say class dice. All right. Now, we're going to have our constructor. So we're going to say def underscore init underscore. Now this is a function just like we've been writing all along, except it just has a weird name. But it has to be called this. 100% has to be called underscore init underscore in Python. In Java, the constructor has to be called the same thing as the class. In C#, the constructor has to be called the same thing as the class. In Objective-C, the constructor can be called whatever you want it to be called. So there's some rules that change a little bit between languages. In Python, this constructor has to be named this way, and I'll explain why in a few minutes when we actually create one of these dudes. It's to support the syntax on the other side. All right? Now, every single function that belongs to a class must take as its first parameter self. That has to be there. Now, when we create a dice, you know, if I go to the awesome person store that sells dice, that's not what they have on the side. the Geeks R Us store. If you go into the Geeks R Us store and you walk up to the counter, you'll say, I want a 20-sided die. And they bring out like a big bucket of them so you can pick the one that has the right color. It looks awesome for your fireballs, right? I hate all of you. Just remember those days like at 4 a.m. when you're like scrounging up like 90 D6s to drop a fireball on somebody and people are like crawling under couches to help you with the count. Yeah, because you get high level in Dungeons and Dragons, and you're gonna shoot a fireball at somebody. That's not just like a 2d6. You know, you're dropping like 90 d6. Yeah, that's what the cool kids used to do. And those asteroid dice were so tiny, we could never find those. All right, so we always take in self. But we're also going to need the number of sides. This is like me walking into the store and saying, I need a 20-sided die. I need a 10-sided die. I need a 6-sided die. Go ahead. Correct. It has to be called this. If it's a constructor, exactly like that, case sensitive and all. And I'll explain why in a second. We're going to have some other things. Yeah, you'll see how it all comes together here in a second. All right, so I'm going to create my constructor. I'm going to say self.sides is equal to sides. And then I'm going to have another method here called roll. And roll's not going to take any real parameters, but it still has to take in self. And what I'm going to do is I'm going to return, this is like me rolling a sides number of sides dice, or die. So I'm going to return randint 1 to self.sides. All right, that's what my dice currently does. Now let me show you how this works. I'm just going to comment out these lines here. We still have all our logic there, but we're not actually fighting anymore. It's a current standstill. All right, I'm going to create a dice D6, and this guy is going to equal dice 6. I'll create a dice D20. This guy will be equal dice 20. I'll print out D6 dot roll. And I'll do that a couple times. And then I'll print out D20 dot roll a couple times. Run this real quick. Oh, sorry. Loosely typed language. That would have worked in Java. Mostly would have worked in Java. All right, so there's my D6. There's another D6. Well, same D6, just rolled it a second time. And here's me rolling my D20 2 times. That makes sense? So now let me show you something here. I'm going to print out D6. I'm going to print out D20. What do we expect to print out when we say D6? what do we expect to print out when we say D20? Notice I'm calling the variable names themselves, not their roll function. Go ahead. That's what roll did. D20.roll gave me a number between 1 and 20. D6.roll gave me a number between 1 and 6. But what is D6 going to give me? Just D6. D6 is a variable that holds the result of me creating an instance of dice class where I passed in 6 for number of sides. Let me show this to you. So it gives me memory addresses. It gives me a memory address. Now let me draw a picture of this for a second. Okay, what we're about to do here is like in the top 5 most important lessons for object-oriented programming. Remember, I mentioned a few minutes ago how important self is, and this in our other languages, but so I have a variable called D6. I have another variable called D20. All right, so these 2 different variables. Now, when I said D6 equals dice 6, what it did is it built up here in memory a dice object. And this dice object has a number of sides equal to 6. It also built for me another dice object that had a number of sides equal to 20. This dice object right here, D6, that variable holds a value that is a pointer. That is the memory address where this particular dice object lives. D20 holds a pointer to where that particular dice object lives. Now, I could come in here to my code and I can say D20 underscore 2 is equal to D20. And then when I roll D20 underscore 2, you'll see this also will give me a number between 1 and 20. But D20 underscore 2 is the same. So here's where I created the value for D20. That's my current picture. Now I created another variable called D20 underscore 2. And I set that guy equal to the value that is in D20. This does not do this. It does not give me a different version of that D20. I'll prove that to you. We'll print out D20 underscore 2. And you're going to see that these last 2 lines print out the identical value. These 2 guys, same memory address. So what this actually does is it creates a variable called D20 underscore 2, sets it equal to the value of D20, which is the memory address, which points to this guy. They are the same object. Make sense? So I have 2 different variables that both hold the same memory address and they point to the same place in memory. Okay? Now, if I'm in my code in here, go into init. And I want to print out D6. Do I have a variable in here named D6? Do I have a variable in here named D20 or D20 underscore 2? I don't have those variables, right? I do have a variable called self. Now we're going to see when I create an instance of dice and I pass in my case here, I passed in a 6 one time, I passed in a 20 another time, we will see that it's going to print out the value of self. And the value of self will be equal to the value of D6 as we're creating this guy. So here, I'm going to move these guys up to just put them right next to each other. So this is how I create a dice, but inside of that creation, inside of that constructor, I'm also printing out the value of self. And you're going to see that the memory address gets printed twice. I print it out inside the constructor. It's called self. It's how an object refers to itself from within itself. I'm going to print it out again right here. Similarly, I'll print out D20 after my D20. And we'll see that that guy, these two will print out the same thing. Even though I'm printing out a variable called D20 here, and I'm printing out a variable called self in here. They both point to the same place. So if I just show you the picture here, this guy here has a variable called self. This guy here has a variable called self. And those variables, let's see if I can make this awesome. Loop back on themselves. So it's how an object refers to itself from within itself. Let me show you this run here. So remember, first thing we're doing is we're creating our instance of our D6, which will print out self. Then we're printing out the value D6 holds. This is self. This is the value contained in D6. This is self. This is the value contained inside of D20. Does that make sense? So self is how an object, this is an object, this is an object. Self is how an object refers to himself from within himself. If we're external to that object, we usually have a variable or even two variables or more that point to him. Because when we're outside, we don't have access to a variable called self. If I'm down here, I don't have access to a variable called self down here. There's no variable that I defined anywhere called self. That all lived and died with my class up here. Make sense? All right, so questions about the self keyword. We kind of understand how objects work right now? So what I'm going to have you do for Wednesday is I want to go through chapter 9 on classes. And let's do 9.1 to 9.6. And then write the summary. Okay? I'll put the Bible homework up today as well. And I will see everybody on Wednesday. Remember, the hackathon is this coming Saturday. You have until 4 p.m. today to sign up for it. You have to email joshua.locklear@cuw.edu to get your name on the list. If you are not signed up by 4 p.m. today, you will not be allowed into the hackathon, and you will either get zeros on 3 homework assignments, or you'll have a really, really, really nasty penalty assignment. All right? So send that email. 1 second.
Sorry.
No.